Namaste. It's me Santosh Kumar KC. As a चाहिँ म चाहिँ यो discrete mathematics सब्जेक्टको टपिक comparing linear and Hamiltonian approachesको बारेमा केही भन्न गइरहेको छु। यसको लागि म हाम्रो facilitators Mr. Sandeep ढुङ्गाना सरलाई सरप्रति आभारी छु। It's me Santosh Kumar KC and today's date is 6th January 20. Now today we just need to overall we just need to discuss the things which we are going to discuss today. The first one is history of Euler path and Hamilton path, and the second thing is vertex. It means node and the age based on this, and the third one is Hamiltonian path and Hamiltonian circuit. And then the next one, Euler path and Euler circuit. And then the second last topic, subtopic, we have a degree of vertex and comparison of Euler and Hamiltonian path. And the last one is solving the. Now let's start the history of Euler path. अब Euler path चाहिँ जुन हिस्ट्री छ यो कहाँबाट सुरु भयो भन्दै गर्दा Euler path was first discussed by Leonhard Euler while solving the famous seven bridges of Kummer's problems in 1736. The problems can state it mathematically like this. You can see on the down. हजुरहरूले पनि यहाँ देख्न सक्नुहुन्छ यो प्रब्लममा सातवटा ब्रिजेस जुन सातवटा ब्रिजेसको बारेमा पोइन्टहरूलाई हाइलाइट गरेको छ। यसो हुँदै गर्दा यो हिमोल्टिनियस हुनको लागि अथवा युलियर्स हुनको लागि के हुनुपर्छ के हुनु पर्दैन भन्दै गर्दा हिमोल्टिनियन भन्ने बित्तिकै हाम्रो दिमागमा चारवटा कुराहरू आउनुपर्छ। एउटा हिमोल्टिनियन भनेको पाथको बेसमा आउनु पर्यो, अर्को हिमोल्टिनियन भनेको साइकल्स अथवा साइकल अथवा भनौँ हिमोल्टिनियसको त्यो भर्टेक्समा सबैको रोटेट गर्दाखेरि सर्कल बन्न पर्यो भन्ने कुरो हो। अर्को भनेको हिमोल्टिनियस सर्किट्स र अर्को हिमोल्टिनियस ग्राफ। चारवटा कुराहरू चाहिँ यसभित्र पर्छ। हिमोल्टिनियसमा पनि हामीसँग क्लोज युलियर पाथ र क्लोज हिमोल्टिनियन भन्ने दुईटा कुराहरू इन्डिकेट गर्न सकिन्छ। जस्तै अब हिमोल्टिनियनको पनि युलियरको हिस्ट्री जस्तै हिमोल्टिनियनको पनि एउटा हिस्ट्री छ। जस्तै हिमोल्टिनियन पाथ and cycles are named after William Rowington, who invented the scones game, now also known as Hamiltonian puzzles, which involves finding Hamiltonian cycles in the age graph of the dodecahedrons. Now we can just talk about the vertex. Our vertex भनेको के हो भन्दै गर्दा vertex is typically means a corner or a point where two lines are meet. As you can see on the figures, हजुरहरूले पनि फिगरमा देख्न सक्नुहुन्छ कि vertex भनेको चाहिँ कुनै दुईटा लाइन्स को corner or the points where the two lines are meet. जस्तै यसमा vertex भनेको दुईटा पोइन्ट्स दुईटा लाइनलाई इन्डिकेट गरेको पोइन्टलाई इन्डिकेट गरिन्छ भने if we talk about the straight lines, only straight line is not a vertex. So as we can see on the figures, in the vertex we have a dot. Clearly we can see on the dot, but the next one is not a vertex, means simply the straight line we have. Now let's talk about the edge. Edge is a line segment that joins two vertices. दुईटा vertices मिलेर बनिएको line अनि the edge is a line segment that joins two vertices. दुईटा vertex join गरेको point लाई नै हामी के भन्छौँ? Edge भन्छौँ. As we can see on the board also, you can see on these pictures also. Now Hamiltonian path and the circuit. Hamiltonian path र circuit भनेको के हो त भन्दै गर्दा in a graph theory, it means according to the graph theory, an Hamiltonian path is a path which visits every vertex exactly the once. Similarly, an Hamiltonian circuit is a circuit which starts and ends on the same points. Hamiltonian path हुनको लागि चाहिँ सबै भर्टेक्सहरू every vertices exactly travel at once. एकचोटि चाहिँ ट्रान्सफर्सल हुनु पर्यो Hamiltonian path हुनको लागि भन्दै गर्दा Hamiltonian circuit हुनको लागि चाहिँ that circles or that's Hamiltonian circuit भनेको चाहिँ के त भन्दा circuit which start and end on the same vertex जुन vertex बाट start भएको त्यही vertex मा आएर end हुनुपर्छ जस्तै as you can see on the board on the whiteboard it means screen also one the line start from the one after two points two vertex two we can move on the third one after third one we can move on the fourth after fifth after sixth after we just need to move on the seventh and after seventh now move on the very first points that is the one. So as you can see on the this figure also, this figure indicates a Hamiltonian circuit as well as Hamiltonian. Now you can see on the three figures, Hamiltonian path and the circuits. Now look at here, they're all together three figures are there. In the very first figure, this has a Hamiltonian circuit. As we know, 1 after 2 points, 1 knots to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and 6 to 7. Ultimately, after 7, we just need to reach on the very first. So ending and starting both are similar points, that is 1. That's why you can see on the first figure is the Hamilton circuits. Now let's talk about the second one. This has a Hamilton path, but it does not have a Hamiltonian circuits. Second figure मा यो Hamiltonian path भन्न चाहिँ मिल्यो तर circuit भन्न मिलेन किनकि Hamiltonian path हुनको लागि चाहिँ every points it means every nodes start from A to as you can see A to B, B to C, C to D and after D again we move to A and A after E. So we can say that Hamiltonian path, but we cannot say that Hamiltonian circuits because the line start from the A. So we just need to move from A to B, B to C, C to D, and after D, again we just need to A. We just need to move on the A. Till A, B, C, D, it's okay. A to B, B to C, C to D, D to A is Hamiltonian circuit, but we just need to include number E also. हामीले E alphabetलाई पनि include गर्ने भएको कारणले गर्दा E alphabets we just need to include it. हामीले include गर्नु पर्यो तर E alphabet छुट्टै छ भनेपछि number second figure is not a Hamilton circuits. Now third one is this has no Hamilton path. If the third figure is not a Hamilton path, it means we cannot talk about the Hamilton circuits. पहिला Hamilton path हुनु पर्यो, path भएपछि now let's talk about the circuits and if Hamilton path is not possible, then we cannot say that Hamilton circuit on the very third figure. It means now let's talk about the Euler path and circuits. Now see, in a graph theory, an Euler path is a path which visits every edge exactly once. Similarly, an Euler circuit or Eulerian cycle is an Eulerian trial which start and end on the same vertex. अब Eulerian path र circuit भनेर के बुझिन्छ भन्दा Eulerian path भन्ने बित्तिकै a path in a graph is called an Eulerian path if it is contain every edge actually once. एकचोटि मात्रै एजमा इन्डिकेट हुँदै गर्दै जाने हो भने that is called the Euler path. But Euler circuit भनेको चाहिँ a circuit in a graph is called an Euler circuit if it contain every edge actually once except first and the last vertex. Now the next one is Euler path and the circuits. There are altogether three figures. As we can see on the three figures, first figure is this has an Euler path and Euler circuits. So on the very first figures, but in the second case, this has an Euler path, but we cannot say that it has Euler circuits. First figure मा चाहिँ Euler path and Euler circuits both are combined, but in second figures we cannot say that a Euler circuit, though the second figure indicated with the Euler path, but it does not support for the Euler circuits. Now let's talk about the third one. It has no Euler path. Now the next one is degrees. Now let's talk about the degrees. Degree of a vertex as the degree of a vertex is the number of edges of the vertex. Degree भन्नाले how many vertex, how many number of vertex are engaged. That number of edges is known as a vertex. Number of edges भनेको vertex हो. As we can see on the figure also, the namings will be A, B, C, D, E, F, G, H, I, and J altogether. Then first alphabets are there. Now in A points, only one degree we have. In B points, B is a single one. Again, B is a single point. Now C, again A, B, C, and all 3 points are a single degree, so 1. But now let's talk about the D. D has 4 degrees. Why, These D points create one line from A, D point create one line from B, D point create one line from C, and the D point create one line from E. So altogether 4 points are merged at the same place, or it means same points, that is called the D. So D has a 4 degrees. Similarly, now F. Now in F you can see only one, it means only 1 degrees. Now G, in G altogether 3 degrees are there. G points are created. G points is created when line start from J to G, H to G, and E to G. It means G, but G degree of G is obviously 3. E has also the same thing, 3, and I only two lines are indicated of I. One is from H and the second one is from J. So I has 2 degrees. Similarly, last one alphabet is the J. So J points indicates these J points created while line are enlarged from G to J and I to J. So the degree of J is, we can say that, 2. Now let's talk about the comparison of Euler's and Hamilton circuits. Now you can see on the very first column is properties, second column is Euler's, and third column is Hamilton. In the properties on the first, repeated visits to a given nodes allowed it. Repeated visits to a given nodes allowed it. एउटै पोइन्टमा दुईचोटि 2 or more than 2 times when we repeat it. Nodes, it is possible. In Euler's, yes, why not? But in Hamilton, no, we can't. Similarly, in the second one properties, we have repeated transversals of a given age allowed it. No, we can say that both the cases, Euler's and Hamilton, both the cases, we cannot repeat it a transversals of a given age. So both answers are no. Now third one, omitted nodes allowed it. So as we know, omitted nodes are not allowed it in Euler's graph as well as Hamilton graph. Now the last one we have, omitted ages allowed it. So omitted ages are not allowed it in the Euler's, but omitted ages are allowed it in the Hamilton graph. So out of these 4 different questions, as you can see, out of 4, only 2 S are there. The first one is repeated visits to a given nodes allowed it in Euler's is possible, but Hamilton is not possible. Similarly, omitted ages allowed it on the Hamilton, but we cannot allow it in the Euler's graph. Now, the last, we are moving on the very last part. So, in the last part, we have 7 bridge problems. 7 bridge problems. In this image, we can see it is possible to construct a path. A path starting and ending on the same vertex, must be the same vertex, which visits each is exactly the ones. Now solve it. I'll give you a certain times to solve these bridge problems, though I will share the correct solution as well. So before that, please solve the given problems. This given problem is based on 7 bridges problems. Okay, now time up. If you already solved, then now move. Solve. Now see. As we know, the first one, an Euler circuit is possible if every vertex has even degrees. See, an Euler circuit is possible if every vertex has even degrees. Degree must be even, then only possible these Euler circuits. Otherwise, if we have odd degrees, then Euler circuit is not possible. The first options. Now, second options, as you can see, an Euler's path is possible, but Euler circuit is impossible if exactly 2 vertices have odd numbers. So on the third one options, no. Euler path is possible if more than 2 vertices have odd degrees. So finally we came to know the conclusion parts. So there is no Euler path in the given bridge. So thank you for your presence.